Hello, sound. Great. Almost great. Hello. Ah, yes. Good. Hi. All right, it's time. Looks like we're in good shape today. Everything worked except the audio was pure bass and sounded like trash, so I canceled my song. I will pick more boring, less bassy music for the future. All right, anyway, hi. So we'll go back to the next lecture. It's less dark today. We're starting on time. We're not just fidgeting with a projector screen or a Zoom link. That is good. So announcements of the day. Reminder, there's this nice checklist of everything you need to be thinking about for the first 5 weeks. So I'm going to show it to you again. This is just a good way to know exactly what you should be doing. And if you're somebody who joined the class late, then there's a how to get started late guide, except you don't have access to it. So I'll have to fix that right after class. But yeah, hopefully these 2 docs help keep you organized and make you feel better about life. And okay, there we go. Reminder that homework 0A, other announcement, is due today. Now, if you're somebody who joins late, like say you're watching this video in the future, and you're like, but that was in the past. There is a way to submit things late if you join the class late. It's in this document, though actually you can't access the document yet, but you in the future can. Good. All right. Other announcement. So if you're watching the webcast, you have the ability to pause time, which is a great power. What I find when I'm watching a technical lecture is that I like to pause when I think I know what's about to happen and like kind of guess. Like when I'm watching like a math lecture, let's say, I want to like maybe guess which way the proof's going to go. Or if I'm watching programming, I like think a little bit about what code is about to get written. And when there's some actual interesting problem solving, I find it really interesting to see where I went wrong or like what mistake I made. So just a tip that I find it a good way to engage with pre-recorded lecture content. Now, you guys, I'm assuming, do you have the ability to freeze time? Probably not. If you do that, I think it's still cool to freeze time and think about what I'm about to do. All right, so just beware. Okay. So today we're going to be talking about 2 topics. One is defining classes in Java, and the other is lists and maps. Now, this is a very big departure from 61B every single time I've taught it for all time. So I have substantially reworked the second half of this lecture and brought forward content that used to be in like week 3 or 4 to today. I think it makes a lot of sense. I think it's thematically beautiful, and it allows us to do the new very cool Project Zero that will be released at midnight tonight. So feeling good about it. But there's so many moving parts. And this is, I think, I was talking to earlier, the student who made the announcement. I think the busiest I've been since I had newborn babies at this moment. So I apologize if there's any little glitches in the slides. I try to make it all perfect, but we'll see how I do. Okay, so let's jump right in to our first task. So I'm assuming you've done homework 0A. If you haven't, that's okay. Ideally, you should have, but I'm going to assume you have some sense of what's going on with Java. And I'm going to start talking about some of the more subtle things. Like I'm not going to talk about while loops and for loops and if statements, but I am going to talk about how classes are defined, because in Java, all code must be part of a class. And therefore, it's quite important to understand what classes are all about in Java. Okay, so as we saw last time, every method has to be part of a class. The term method, by the way, is a function that is part of a class. So in Python, some functions are just functions, and some of them are methods. They're part of a class. But in Java, because all code is part of a class, all functions are methods. Okay. Now, to run a class, we have to define a main method, which just had this magic public static void main string args thing going on. But not all classes have to have a main method. So let me alt tab my way over to IntelliJ here. And let's also make this much larger so you can see. And let's also open the right file. So I'm going to have here the dog class. Move this over here. Oh, by the way, if you're on Zoom, you can ask questions, and I have 2 folks around who can answer them for you. So class dog, I'm going to have a method which I'll call public void make noise. And void here just means it doesn't return any type. So it doesn't return anything. It's not its job. It only has side effects, like, for example, printing out bark. Okay, and this function lives as part of a class, but there's no way to you can't just run this class. It's not even a run button. I can make a stop sign looking thing appear, but I cannot run it because there's no main method. I could add a main method. I could say public static void main make noise, run this program, and run this main method. And I would get, oh, I forgot one thing, public static. And we'll talk about what that word means later today. But here, this creates, dog problem. Okay, I have a dog problem, which is I'm going to comment on everything in this file. One thing about IntelliJ is it checks every single file in your whole directory. And since we haven't done certain things, the code won't actually run yet. Okay, one moment. Ignore this moment. What is that? Okay. Oh, no. Okay, here we go. Got a plan. you guys go away for now, and we'll get back to our dog here. Okay, so the dog class, now we can run this hopefully. Okay, we get Bark. There it is. Very small dog. There's Bark. Okay. Now you might wonder, what's the difference between these two run buttons? Nothing. Okay, so you can run either one you want, or you can do the one up here. There's many ways to run. You can use the keyboard shortcut. All of them do the same thing. Okay. Now what I noted is that not all classes have to have a main method, so I can get rid of this. And you might wonder, why would I do that? We'll get there. But I could have a separate class, which I'll call dog launcher. It's used to launch the dog class, I suppose. And I'll have here a main method. And in this class, I could say, hey, dog class, you make noise. And there's no reason to be doing this. I'm just doing like syntax gymnastics. But if I do this, I will now get my Bark. I should change the default font size, but I haven't. Okay, any questions so far? So just kind of not super exciting stuff. Yeah. Oh, PSVM, public static void main tab. Yeah. Yeah. Good question. Those type of labor-saving tools are great to know about. Yeah.
Does the new asterisk do anything?
No, this right here is an annotation. I actually don't know what's this one. It is a CodeVision inlay. I'm going to hide all of those because we don't want them. All right, good point. That was not real code. That was IntelliJ adding some things that were supposed to give me some hints about something. I don't know what. Yeah. Yeah. Right. When you push the green arrow, basically in IntelliJ, it invokes that method. Yeah. Or if you're thinking about the 61A workflow, it'd be like when you type Python space myhomework.py, like the main method is what gets run when that happens. Yeah, so I don't want to touch that kind of thing yet. We'll get there later. I'm not taking away the word static. We will later. Yeah. So the question was, is this how dog launcher knows about the existence of dog? Kind of. The answer to that's actually a little intricate and involves something called the class path that I don't really teach in this class. But suffice it to say, if they're in the same package, then yeah, they can use each other. Yep. And I'm specifically not really talking about this. There is that extra line of code that I apologize for not really going into. Maybe we will later, but I'm just gonna leave it be. You can leave it a package as a folder with a bunch of Java files in it. Yeah. Well, in this case, I did. So earlier I messed up and forgot it. But we will in about 10, 15 minutes talk about why you would get rid of the word static. Yeah. Other questions? Yeah, one more.
Why are the parameters for the main method strings?
Ah, great question. What are these strings? So in your 61A, if you took it, sometimes you would type like Python space myhomework.py space, and you can have extra arguments there. They basically are ways for the operating system to give information to this program about what it should do that's different. We won't do that today. Maybe at some point we'll do this, but it's more useful for command line programming. We'll use it in project 3, but I don't think we use it before that. Yeah. Cool. All right. So I don't know why I'm on that slide. Okay. So yeah, this is the slide summary of what we just saw. This is a class called dog. It has no main method. You can't run it directly. This is a class that has a main method that calls a function that's part of another class. Now, not all dogs are equal, which I bring up because we should have, I don't know if I shared sound, but we'll do it so that the people on the internet can enjoy the sounds of these dogs. So one of the reasons we write code is we want to recapitulate features of the real world, right? Chemistry or whatever else. And so in this case, maybe we want to be able to capture the fact that there's different dogs. So here is one dog, how it behaves, assuming this video is still up. Let's find out. Uh-oh, okay. There you go. Okay.
Don't call the door.
Sorry if you have headphones on right now. This is a really good dog, though. Beautiful. And I know it's kind of quiet in the back, but that's just how the dog is in the audio. Okay, the other one, I'll try and get the sound working properly so you can hear this dog. Hold on. Is it worth it? No. But I'm going to do it anyway. Okay, let's see what happens. Okay. Pray for our ears. Just kind of opposite style of dog. All right, anyway, so that's what you're paying for college. You work out your tuition, divide by the number of minutes in class. I think you paid like $2. Okay, anyway, okay. So we could create a different dog class for every kind of dog, but that gets redundant. We don't want Maya the dog or a yapping dog as two different sounds. So this sort of silly example portrays maybe in some rough sense why we want what we'll now call an instance variable. Okay. So classes can have not just functions, like our classes so far, they just had methods, no data, but you could put data in them. And you've seen this whether you've written MATLAB or Python code or C code. So for example, we might have each dog having a size or a weight in pounds or whatever. And then what we'll do, I'm just going to start dropping some terminology on you, assuming you know what I'm talking about, even if you don't quite, but we'll get there. Classes can be instantiated. And once you do that, you're basically saying like idea of a dog, you're real, right? You instantiate it as an object. And so there's just one dog class, the Platonic ideal of dogs. And then you have instances of that dog class. And so you can think of the class as like a blueprint, a machine that generates these dog objects. And so in this example above, where I say dogs have a size, we know that all dogs have a size. Okay, so let's try it out. I'm going to go and just do this in IntelliJ. So in my dog class, I'm going to go in and I'm going to add a variable, which I'm going to do by having public. And now instead of public static void, whatever, I'm just going to say public int. So I want it to be an integer, and I'll do size for consistency with the slide. And that's it. There's no like stuff, right? It's just a variable. Okay, so that's the size of my dog. Okay, and now once I have that size, I can do stuff with it. So I'm going to say, if the size is less than 10, for example, then I am going to make a yap noise, I guess. That's a yap noise. If my size is less than 30, oops, typo, then I'm going to make it like a bark, sort of a dignified bark, but nothing too dramatic. And then if I'm even larger than that, in that case, then I'm going to have an aroo, which is like a beautiful sonorous Malamute noise. Okay. Now you'll notice the problem here is that I have size, and I know that's way too small to read, but I'll tell you because the words don't even make sense to you. But it says non-static field cannot be referenced from a static context. Okay. For reasons that we'll get into soon, it's complaining that static shouldn't be here. Okay. So this is where I'm starting to bend the rules, my simplifications that you use public static for functions. I've taken away static, and now I can use that size variable. When size was here, oops, when size was there, when static was there, we can't use the size. When static's gone, we can use it. And I promise that that will make total sense by the end of lecture. Also, by the way, let's make this a little bigger so you can see all the code. Okay, so that's a dog. Let's go into dog launcher. So I do dog.makeNoise. And now I get a warning that says non-static method cannot be referenced from a static context. Okay, again, kind of makes some sense. And what it's getting at is that you're telling the idea of a dog to bark, right? But the idea of a dog can't bark. We need a specific dog. So we can have a dog. Please give me a dog name. Janice, perfect. Okay, dog Janice. And then I'm going to say new dog. So that creates the dog. There's a special keyword new that says the class on the right side, I'm making a new dog. And then I can set Janice's size. And then I can tell Janice to make noise. So it's a specific dog that's going to make noise. And I'll talk more about the syntax. I just want you to get the idea now. We're going to hammer the syntax for the next like 7 minutes. So if we do this, we get a yapping noise. Janice has yapped. If we make Janice absolutely gigantic, then we'll get Aru. Okay, there you go. Okay. Questions? Yeah. Dog doesn't work, just doesn't work. And the reason was we added the word static, or we took away the word static rather. And we'll go back over that, but that's the reason. Yeah.
Is there like an opposite of static, but it requires?
Yeah, that is the opposite. So if you don't have static, that means it has to be instances. Yeah, yeah. The lack of static, non-static is that. Yep. Like that, no. Yeah. So unlike Python, it doesn't work like that. Python has the self argument. Very good question. Yeah. Let's see. Could we do dot notation on what? Well, we have the instance. This is that. We create an instance of the class. So what do you want me to do with Janice that I'm not doing? Oh, in the same line. I see. Yes, you could do new dog. So just like 61A, this thing is a argument that, or this is a So I could say new dog dot size equals 5, right? So that will work. It creates a dog, sets its size to 5, and then we don't have access for the dog anymore, but it does technically work.
On a non, static int variable. then we have
Mhm. Yeah.
also Set a number to it, like,
Like up here or something?
Yeah.
Yeah, you could do that, and then that would be like the default size for all dogs unless you change it. Yep. But we'll see something a little different in a second. Yeah. Why do we have public in front of everything? You can get rid of it and the code will still work, but I'm doing public for a reason that I'll talk about later. Yeah. Wow, we got a lot. This is cool. Okay. Yeah. Sure. You. Yeah. I don't know. Maybe got a bug, but yeah, when I do it, when I run it with 50, it works. So basically you tried it solo and something was going wrong. If you did it with the code, I don't know, I have to look at it later. Good question. Yeah, go ahead.
So if the make noise is called, I guess, without manually setting the size of, some specific dog, is there something like default?
Ah, yeah, right. What happens by default? That's a good question. It's 0. Yeah. Yeah.
How would change then?
So we can't really, well, I should be clear that Janice doesn't really have a name. This is a variable that we've just bound the idea of the dog to this name, but we could have other variables like A and A equals Janice and all that. And we'll talk about that next Wednesday. Yeah. Yeah. Right. Okay. I was trying, but I should try harder. Okay. Yeah. Go ahead. Yeah, I'm gonna take like 2 more. Yep. Make calls outside of the class. Yeah, you can't have any code out here. That's the point. Yeah. Always part of a class. Yeah. When I created size, when I make it public int, as opposed to what? Just int size. I'm always doing public for now. Later, I'll talk about what it means to put public or private, but not today. Just doing public because it's the simplest to understand. Cool. Oh, one more. Yeah. Right. If you take away static here, then it won't run because the contract with Java is that the method that runs when you run a class has to be public static void main. You'll notice my green arrow went away. So that's what happens if you get rid of static. Cool. Okay. So plowing on into the world of terminology. We just did that, right? We added a size variable to each dog. All dogs follow that blueprint. They have a size. And so what we're going to do next is get something closer to this. So this is the code I'm about to create. And the goal is the way we were creating dogs and setting their size was awkward. So that is, I had to actually like create the dog and then set its size later. If we go back to how we had things, so let me go back here. So what I'm going to do now is I want to change the code so I could just say 50 here. And when I do that, that'll be more like what you're probably used to, say in Python, this idea that there's a constructor where I give it a number and it just creates a dog with a size, and I don't have to manually muck with all of its instance variables, which is generally considered bad style. So to do that, I need to create a new thing up here, which is not a method, it is a constructor. So I'm going to say public dog, and here I didn't even put a return type at all. And then I give my parameters, and I'll do S, and then I'll say size equals S. That's it. Okay, so size equals S. And once I do this, my code will work. And in fact, I'll show you a little preview of what we'll be doing in lab next week. I'm going to set a breakpoint here. And so if I run my code, actually, I'll set it right here. If I run my code now and use this bug button, what you'll see is the code will stop on a certain line once it runs. It's starting. There we go. Stopped on this line. I can click this visualizer button. This is all of the things in memory. I'm going to use the step in button. And I can see the constructor starts running. This is very small, and I don't have my Mac set up to zoom in nicely, but I'll do it for next time. But this is the default size of 0, very small, but this is size 0. There's a few pixels. It gets set, and then we're done. Okay, so anyway, you'll play around with that next week. So that's our constructor, right? Any questions about this? Yeah.
So that size variable, particular to the object that you're creating.
Yes, every dog has its own size. So every instance you make has its own size box. The question was, do they have their own size box, by the way? Sorry, Sue. Yeah. Yeah, the constructor, was the question, does it always have the same name as the class? Right, yeah, has to have the same name. Yep. You can have multiple constructors with different numbers of parameters, yeah, or types.
How do you set a default?
You can do a default by just putting it up here, and that's fine. It'll do this. That's kind of a weird thing because it would default to 5, and then it would get overwritten every time you make a dog. But yeah, something to play around with on your own later. Yeah.
You combine two and execute the variable at the same time.
Combine the two what? Can you combine the two whats?
So you have public in size, and then you also have the same. Can you instantiate the variable within it?
Oh, right. So yes, if you do int size here, this won't work because this is a local variable to this scope. Yeah. So it has to be up here. And by the way, common bug in Java is to do this. This creates a new local variable that hides this one. Anyway, yeah, don't do that. Yeah. Constructor. Yeah, why is there no static in the constructor? Because there are no statics in constructors. All right. Yeah. All right. Cool. So if you want to compare, this thing's just been sitting on the screen. I don't even see it. Sorry. I can get rid of that. So if you want to compare the Java and Python versions, this is the Java version. I did weight in pounds when I did the slides before. It's just size. And over here is the equivalent Python code. So you can compare those two later if you like. Okay. Cool. So that's defining and instantiating classes. Now I'm going to have a boring but important few minutes here of terminology. So in that class, let's just talk through the words people use for these things. Up here, weight in pounds. Nope, don't need that. Okay, bye. Leave. Okay, I don't know why that happened. There it goes. All right, so I just switched back from Windows to Mac after 7 years, so I'm a little sloppy on it. I don't know all the cool tricks, but by the way, the reason I switched, I used the student's M1 MacBook in my office hours. It's like, oh, it's too good. This is like so responsive. It's very fast, and it's very fast, so I'm into it. Anyway. I resisted firmly Macs for a long time, but this computer's too good. Anyway, so here the dog class, this weight in pounds, it's an instance variable, and you can have plenty of them. You can have 100 or 1,000 or whatever you want. This one has 1. This is a constructor, which is similar to a method, but it's not a method. Tells you how to instantiate the class. Then we have a non-static method. These are also called instance methods. And the idea is that if the method's going to be invoked by an instance of the class, like Janice, you bark, then you should say non-static. In other words, if the method needs to use my instance variables, or I am Janice, this, you can imagine yourself putting yourself in the mind of Janice. That's what happens here. Then it needs to be non-static. Okay. Now, another thing I want to note is you can't add new instance variables to an existing object. This is unlike MATLAB or Python. I cannot say, hey, dog, you also have a name now and your name is Frank. That doesn't work. Can't do it. Okay. Java is very strict about these sorts of things, and it makes life good. A few more exciting terminology pieces. So if I only do dog, small dog, that's called a declaration of a dog variable. No actual dog gets built. You just have a little home where a dog could live. When I do new dog, this is instantiation only. Now, this is a somewhat cruel process because this creates a dog, but then it doesn't go anywhere. It's a little strange. It has no effect on anything. And there's something called the garbage collector I'll talk about later, but not now. But this dog succumbs to the garbage collector immediately. All right. This is instantiation and assignment in the same line, where I'm going to both instantiate a new dog and assign it to a variable. So this equal sign is the assignment. And there's all three on one line. Okay, so just want to make clear that there's 3 distinct processes: declaring a variable, instantiating a thing, and assigning it to the result of a new to a variable. And then one more term is invocation. So I can invoke the dog's make noise method. And by the way, this dot notation, which you've seen no matter what programming language you came from that I know of, this means a member of that class. Not taking questions on this one, I think, unless you, okay, you really wanted it. Go. The variable, we instantiate, and they're in the same place. Yes, basically. They're both in the heap. Yeah. Okay. This one, though, I'll let you stew on later. It's too boring to go into detail. All right, now let's talk about the distinction between static and instance members. So I showed you two different methods, ways to write make noise today. I had the static version where just the idea of a dog barked. And that one at the very beginning of lecture, before we knew what we were doing so much, we were telling dog, make noise, and it was barking. That was when we had dog and dog launcher. Then I said, not all dogs are the same. So I took the static away and I said, now I have a dog with a specific set of properties and it's going to make the noise. So I go from static to non-static. Okay. So the key differences are static methods are invoked using the class name, idea of a dog bark versus Maya bark. Instance methods are invoked, of course, using an instance name. That's what I just said, okay, Maya instead of Janice. And the other thing is that static methods cannot access their instance variables or my instance variable because there's no me. So if I make this method static, then it doesn't really make sense to try and access the weight in pounds because there's no specific me. Okay. Classes, I should note, are not necessarily instantiated and all of their methods are static. So for example, in Java, there's a class called math and it has a method called round. So math.round 5.6 rounds that number to 6. And that's a lot nicer than having to take math and instantiate it. I mean, you could write math that way, but that's not how it's written. It'd be kind of awkward to have to instantiate a math and then tell that math to round. And classes can actually also have a mix of static and non-static methods. So for example, let's just go in here. I could go into the dog class and I could say, let's make a method for comparing dogs. Public static dog, max dog, and it takes two dogs and it returns which one's bigger. So if D1 size is bigger than D2 size, it returns D1, otherwise it returns D2. So this is a static method. And the idea is that the dog class now, like I can go into dog launcher, I can create another dog. I need another dog name. Charlie, perfect. Okay, Charlie is 9. And we could, oops, we could ask the dog class to resolve the question. Who's bigger, Janice or Charlie? So this is like appealing to the god of dogs. Like, you're going to be the judge. I got two dogs for you. I need you to think about this and then compare them. Right, okay. Oh, I forgot to return the value though. I think maybe. What dog do you want to? Why is it yelling at me? What's my error? Oh, I'm not doing it. I'm not doing it. Oh, that's what's yelling at me. I resolved the answer, but don't do anything with it. Like questions about this. Yeah. Sure. Yeah, so I could, for example, have public dog, max dog, other dog. And this would be, hey, dog, I want you to compare yourself with somebody else. So if my size is bigger than other dog dot size, return something. Other way to return other dog. Anybody know what you do here? Java experts? How do you return yourself? This, right? Okay. So this is the special keyword that refers to yourself. Okay. So you can have both. It's just like a stylistic question. Do you trust God to do the judgment? Or do you trust any dog to compare themselves to another? It's a philosophical difference. Okay, so if you wanted to use this other max dog function, you could also say, Charlie, you seem trustworthy. Who's bigger, you or Janice? Yeah. Static is, it's not even necessarily any instance of dog. The question is that for any instance of dog, it's just a method where you don't need an instance. It's like math.round. That has nothing to do with maths, right? It's just like take some number and does something. Yeah. And these are things, by the way, that you'll explore throughout Project Zero to some degree. Yeah.
The instances of the dog class with Janice and Charlie, I noticed that it's like S colon and then the size.
Yeah, so this S is also an annotative thing. And if I don't want it, I can say disable hints, I think, or what's the thing? Yeah, so that S is not real. This is just reminding you what the instance variable is. Yeah, so don't be fooled. Sorry, I just like my brain doesn't even see it. I apologize. Yeah. Cool. Good observation. So that's one of the things about IntelliJ. Let's see, I want to disable. Oh, there you go. It's gone. Again, you're good at that. I was like, what is that thing you're typing? I'm not. It's all IntelliJ. Cool. Okay. Now, one thing I want to know about static variables, they can be a little dangerous, and they exist also. So I can create an instance variable, a variable for a class that's not an instance variable. So I could go in here and I could say, all dogs have this thing in common, their scientific name. So that's the word for a scientific name, Canis familiaris. And now all dogs have that property. Okay. So classes can have static variables like that one. And what I'll say is you should always access them if you ever have to use them using the class name, not an instance name. So you should say dog.binomen, or however that word's pronounced, binomen. You shouldn't ask Janice or binomen, in my opinion. Yeah, I just think that's a strange thing to do. What's even worse is to go to a specific dog and say, you are changing your type. You're now a fox, because now all other dogs are that type. Maybe what I'll just say is like, this capability exists in Java, but it's dangerous. Also known as a global variable. You don't really want to have static variables whose values change. I don't think you'll be tempted in the near term, but I will remind you never to do this. But right now, you're already like at the limits of what you can follow. So understanding this warning when you're still trying to really wrap your heads around static versus instance makes it tough. But if you want, you can read more about this, like why it's bad to have static variables that change. Anyway, perhaps I shouldn't have told you they exist at all, but people like to ask. Okay. So class, I just want to close out on our class thoughts here, can have a mix of static and non-static members, right? So a variable or method, so weight in pounds or max dog, those things are called a member of the class. This one's data, this one's a function. In static members, we do use them all over the place, like math.round, and you want to invoke those using the class name. And that's how you should do it. You could technically use an instance name, but you should use a class name for a class member. Non-static members, you literally can't do you can't access make noise if you use the class name because there is no me. And static methods, they have to access instance variables using a specific instance. Let me give you an example real quick on that one. So if I go over here and in my my max dog method, if I were to just try and say like, print my size, it's going to yell at me and say, you don't have a size because this is a static method. Okay. So just be aware that in a function, like max dog can access instance variables. You just have to say whose instance variables. Okay. I feel like I've stretched your brains a lot though. So I'm going to leave it to homework 0B to let you mull over this sort of thing. And so instead, I'm going to talk about my second topic of the day. Here, I think this stuff should be easier to follow. It's a lot of subtlety in the static, non-static stuff, but you'll definitely get it. Right? It's just when you first see it, it seems a little strange. Okay. So let's talk about lists. So in programming languages, there's something known as a list. You're going to be using it a lot in homework 0B and in project 0. It's an ordered sequence of objects represented often by, this is the usual shorthand, like the list of the numbers 3, 6, 9, 12, 15. And so lists in a given programming language support a bunch of different operations, like adding an item to the end of the list, retrieving an item by index, like what's the 0th item? It's 3. Removing an item, like I want to get the 9 out of there, or I want to get the second item out of there. And so you can read like the world's take on this idea of a list, but I'm just going to take it as rather than giving you a mathematical formalism, which maybe you'll do in some other programming languages oriented class, I'm just going to say, you know, basically what a list is. So Python lists, even if you've never done Python, they're pretty simple. You say, hey, I want a new list, and you do it by saying empty brackets. And there's not a Python class. I'm just mentioning it as a foil. That's simple. And then I say I'm throwing an A in the list, then a B, then a C, and then I print L, ABC. So let's try and do that in IntelliJ. That's going to be our goal. So we're going to go to our list demo. And I'm going to start by writing code that will terrify my TAs, but I'm doing it anyway. I'm going to say list L equals new list. That's going to be my goal. Okay. This is the first version. The first problem I have is that it says, I don't know what a list is. Here I need to import list. So to do that, I'm going to press option return, and then I'm going to click this little list thing. And it's going to add this code to the top. I could also have manually typed that and written import java.util.list, but I recommend you learn the keyboard shortcut. That's the first thing I had to do, import lists, because they're not right at the center of the Java language, unlike in Python. So I say list equals new list, and now it's yelling at me and saying list cannot be instantiated. Well, it seems like a problem. Okay, it's abstract. Okay, so the next funny thing I have to do, and this is just jargon, I have to pick a specific type of list. As we'll see in a moment, there's many types of lists, and so I'll say new array list. Okay, what's an array list? Well, I got to import that too. Let's type a list. Once I've done that, I now have a list that I can start adding things to. Like I can add A, I can add B, and so forth. Okay, I can even maybe print this thing out. And that's how I create lists in Java. So I'll show those side by side, and I'll talk a little bit about the weirder parts of that syntax. Okay, we get ABC. There it is. Okay, it worked. Okay, So this is the slide version of the steps we just took. That's where we got. So the code on the left, Python, code on the right, Java. This is what I call a Java 4.0 list. Okay. Any questions about that? That's our launching point. Yeah.
Can we just import using Java util and the abstract?
Yeah, there is a star, Java util star, but I'm not doing it because I was doing the alt enter thing. And if you import everything, I mean, you can, but I typically recommend not doing star imports because who knows where you're getting along with the ride. Yeah. So I could do array list L equals new array list and that would work. But I want to draw a distinction thematically for the course. Yeah. Some of these questions, by the way, Zoom, I'm not repeating because I think they're clear by context. Okay. All right, that's our first list. Okay. So now I want to talk about this really interesting distinction that Java makes that Python doesn't, which is the difference between an abstract data type and a concrete implementation. Okay. So Java has lots of other types of lists. In fact, if you click this link, you'll see them. We got abstract list, abstract sequential list, array list, the one I just did, attribute list, copy on write array list, and so forth, stack, vector. These are very weird. I don't know why stack's there. I'll complain about that maybe later. And so I really got to learn that shortcut. Okay, what is it? I want to full screen it. Okay, it's like I click a link. I feel like I don't know, someone much older than myself when that happens. Okay, here we go. So we could, instead of using array list, instead of array list, I could have picked linked list and it would have the same functionality, right? It does the same things. It depends. You could print it out, whatever. I can go in here and the code I write is going to behave, basically exactly the same. It's going to have the same semantics, right? The output of everything that happens above the layer of abstraction is the same. Still going to print out ABC. Okay, that's very different than Python. Okay, so in Python, a list is a list is a list. You have no choice how it's implemented. There's no distinction between an abstract list and some specific implementation. For the most part, the programmer has no idea what kind of list is really running under the hood. Dictionaries, maybe in Python, you might have used sorted dict or something else. Sometimes you do actually start picking a specific data structure. But in Python, the way that you usually at a basic level think about a list is just a list. But in Java, you have to decide which kind of list you want. That's going to be part of the debate that we'll have in our class. That'll be like a major theme, understanding the differences between them. Okay. So there's another name for this in the idea of computer science as a whole, which is an abstract data type. It's a list of operations that each list is supposed to have. So for example, Java lists, you can append to them, you can delete items out of them, but there's no reverse method. But maybe in some other language, there is a reverse method for their lists. And each implementation, instead of it being called an abstract data type, is a concrete implementation. So the code for these different types of lists may be radically different, but they all have all these same basic operations. Okay. Now we're going to talk about this in more detail in about 2 weeks, like exactly how this works from a syntax perspective. But for today, you just need to know how to use them. Okay. I'm just going to keep plowing on this one, though, because I don't want to get bogged down by this philosophy. Question for you, though. Why do you think they even bother having multiple implementations? I'm just going to solicit a thought. Yeah.
Maybe one's more efficient.
Yeah, one might be more efficient than the other with certain tasks. Great answer, right? Certain cases, one could be better than the other. Another reason, which is a little more subtle, is that some may have extra operations. So it's a list and also it can do some other stuff. Okay, we'll get back to that next week. But for now, we're going to modernize our lists. Okay, so now we're going to take our list and make them look like something the TAs would be comfortable with, which is modern Java lists. Okay. So in Python, you can get items back from a list using bracket notation. I can say, give me the 0th item from the list. With this list demo over here, if I try and do the same thing, if I try to say system.out.println l.get0, it works perfectly fine. So by the way, instead of it being like a bracket thing, in Java, you have to say l.get. Okay. Now, the funky thing about the code we've written is that if we were to say string x equals l.get, we'll prove it to you. We'll go into IntelliJ. I say string x equals l.get0. It yells at me and it says, you are supposed to give me a string and you're giving me an object. Okay. This was it's like a quirky feature of the Java language that until 2005, everyone had to do another extra step, which I'm not going to teach you because it's obsolete now. But it was just a weird thing that you couldn't just say, hey, I want my string back. Okay. So what we're going to do now is I'm going to take you all the way forward in time to the year 2005, when there was a new feature added, where if I want my list to allow me to get back things by their correct type. Uh-oh. Uh-oh. Things are bad. I'll switch it back to Windows. Is my Zoom still going? Okay, what do I do now? Alt-tab's not working. We are in danger. Okay, what's the next? Give me another keyboard shortcut that might do anything. There we go. Something happened. That's a good sign. Maybe. All right. Oh, okay. We got to the end of the lecture. Okay, cool. Okay, cool. So what we do, oh, everything's better. Steve Jobs, his ghost has released us from the curse. Thank you. So what we're going to do next is I'm going to add a new thing where I'm going to say, this isn't just any old list. It's a list of strings. And then over here, I have to add a little empty diamond. And at that point, now it'll work just fine. Now I can say string X equals L.get0, and we'll capitalize string properly. Okay, this is just pure fiddly syntax stuff. There's like no reason or rhyme to any of this. So let me talk about it a little. So the new thing I'm adding here is when I said list L equals new array list, here all I've done is said, okay, this isn't just any old list. This is a list of strings. That's a new thing that in 2005 was introduced. Once you do that, this is just how lists work these days. Okay. All right. So let's reflect on this just a little bit here. So actually, what I note here is when you do this, lists that use this special notation, they all have to have objects of the same type. Whereas the old style pre-2005 lists, you could put integers and numbers and whatever else you want in there. But once you do this, it's just a string. Okay. So basically going from Java 4.0 to Java 5.0 in the year 2005, if you use the newer style list, you can have lists with multiple types. Why might that be a good thing? So they were given up power. Yeah. Yeah, it makes some tasks easier. Like if you want to iterate over the list, you know everything's a string, right? Yeah. You have to account for the situation where you have multiple types. I think that's a great answer. It just, my take is it restricts the set of choices you need to make as a programmer. You know it's always a string. And so I'll say that I think philosophically, putting limitations on yourself is very good. Freedom leads to complexity. Complexity is hard to fit in your brain. And that's what makes programming hard. And Java, one thing I love about it is it gives you a lot of ways to restrict yourself so that you can't do things that you would otherwise want to do. That's going to be a recurring theme. I'm going to keep pointing out these things that Java has, like static types are an example of that. Having lists that are only one type, another example of that. Okay, that's lists. And you'll get some practice on homework 0B. So I'm going to leave all the like little questions about how lists work on a deeper, more syntactical level to that homework. Okay, we got arrays. So Java has a version of a list that is wimpier than a list. It's a special thing I call an array, or that everyone calls an array. It's basically a list, but very restricted what it can do. So first of all, you have to pick the size in advance. So unlike a Python list or a java.util list, you can't add more things to it. It's like you say it's size 5, for example. This is the syntax. I'll talk about it in a second. But this list is of size 5, and it has exactly 5 things, and we'll never have less, and it will never have more. 2, well, I just said that. The size can't change. 3, the items have to be of the exact same type. And arrays don't have methods. So you can't say like dot largest or dot reverse or whatever. There's no methods at all. And the syntax is very similar to what you get in Python. So I'll say like x of 0. So the syntax here, if I want to do an array, let me just do a live code because I think it sinks in a little better if I do that. I guess I'll do it in this function right here in the list demo file since I don't seem to have a file for it. So what I'll do is I say string array x equals new string 5. That's how you create the array. And then I can start assigning things like Janice or whatever. All right, questions about that? If any, yeah. Great question. Why would you use an array instead of a list? It seems bizarre. Why do you think so? Why would you add this extra list that's worse? Yeah. Runs faster. Yes, good insight. You might have some secret knowledge. The main reason is arrays are more performant because every single item is of the exact same type. The next layer of abstraction down that we're hiding from you, it just works better if everything's the exact same size. 61C, we'll talk about this in some detail. Basically, reading and writing from them is faster. They can do pointer arithmetic, for example, and it uses less memory, right? There's not this extra level of indirection like Python lists. You have to like go somewhere and then go somewhere else. It's a little beyond the scope of the class. 61C. Okay. But be aware they exist in Java. Okay, so Java, you'll notice, they could have chosen to make the list the part of the language that uses bracket notation, but they didn't. Lists are not like core to the language. You have to do like instantiate them and call get and add and all that stuff. But arrays are so important that they get their own special notation that nothing else in Java has. Why would they make arrays like their favored child? Why are arrays the favored child in Java and lists are the favored child in Python? Tough one. Yeah. Java likes restrictions, sure. I think that's a reasonable choice. There's like a deeper one though. Yeah. Oh, more unique. That's a good point. No, it's not a marketing gimmick. Yeah.
Kind of the difference in design philosophy, right?
Right.
I want that to be simple,
Mhm.
lay your thing out. It's either like stretch code,
Right.
that's like pseudocode.
Yeah. Python is meant to be beautiful and elegant. Yes. Java gives you more control, but also Java's meant to be performant. Yeah, so I think that Java is a language that's built for performance. Python's supposed to be beautiful. When you take 61C, you'll learn C. It is even uglier than Java in many ways, and it's even more oriented around performance. It gives you more control. It exposes more things to you. Its defaults are, it's more like the machine, so you get more control, okay? So there's like a hierarchy where Java is pretty damn fast, and like Python's a pretty slow language generally. There's workarounds, but that's it at heart. Okay, I took a lot of questions earlier, so we're gonna do maps, and that's all we got to cover, and I'll be happy to launch you into the world. Last abstract data type of the day is the map. Now, luckily, you already know this. It's a mapping from a key to a value, or you can think of it as a collection of key value pairs. Every key is guaranteed to be unique. These are called dictionaries in Python's, associative arrays in theoretical computer science, and symbol tables, as far as I know, only in Princeton's 61B equivalent course. I mention it only because I taught there for a while and we use their optional textbook. So if you see symbol table, it's the same idea as a Python dictionary. It's like alpha is the first letter of a Greek alphabet. Potato is a starchy edible plant. It's another really important abstract data type. Okay, here's a Python map or dictionary. I create an empty dictionary. I say cats meow, dogs woof. These are the keys. These are the values. And I can retrieve them back. Now, I would do this in IntelliJ, but I was having such a great time answering questions that I'm just going to expose it on the slide. So in Java, the code looks like this, very similar to before. So I say map L equals new map, but I can't just instantiate a map because it's an abstract data type. So I say, hey, we're going to pick a tree map. How do I know that exists? Because I've taught the class a lot of times. Okay, so that's a specific type of map. And you'll notice there's two different values I had to pick here for types. So I did string to string, but this could have been integer to string or string to integer or string to list of strings or whatever. And then I can associate dogs woof, cats meow, and what sound does a cat make? Okay. And again, homework 0B is where you get practice. Obviously, I don't expect you to be able to write any code on this, but this is going to be the heart of Project Zero. Okay. All right. I have about 30 seconds for any questions about this, if you got them. Nope, not ready. No squeaks. Yes. Too many squeaks. If you create an array, I'm sorry, people too rude. All right, I'm gonna finish class, but catch me after class. All right, so last thing I wanna say, okay, to summarize, we got lists and maps. They're abstract data types. You can pick what specific implementation you want. And in a way, the first 4 weeks of 61B are gonna be really thinking about this side. And then right after we do our midterm, it'll be about this side. So last thing, get started on homework 0B. If it's not out now, it will be in not very long at all. Project Zero is out at midnight tonight, and make sure you know the checklists exist, and less squeaking next time. Thank you, everybody.